In this advanced session, we will cover the different ways you can test SQL Server deployments at various stages.
So this means that for the next 60 minutes or so, we'll go through various topics relating to testing your deployment pipelines in Azure DevOps. First, we're going to show you how to deal with testing in your pipelines, and then we're going to show you how you can unleash the testing of your CI/CD pipelines without the need of any of those pesky spreadsheets. So during the session, we will cover how to use T-SQL-T and Azure Test Plans within Azure DevOps. And we're going a little deeper into T-SQL-T and Azure Test Plans than before. And by the end of this session, you will have gained knowledge on how to implement testing at different stages and how to do and in different deployments.
Sounds good, Sander. Before we go any further, shall we introduce ourselves?
Yes, shall we? So I'm Sander. I'm a data platform engineer at Data Masterminds. I have over, well, almost like 20 years experience in IT, and I started working with SQL Server since version 7, something like that. I'm a huge PowerShell enthusiast, and recently became renewed for my MVP for Microsoft for the development platform, which means I do a lot of stuff with PowerShell and other development related technologies. I'm a major contributor to the DBA Tools project, and you can find me on various social media platforms, including Twitter, and I also have a blog, which I try to write as much as I can, but time doesn't permit that all the time, all over. If you have any questions after this session, feel free to send me an email on the email shown in the slide. And all the demos you'll see today from me are on my GitHub page. Find any related the Azure DevOps session, and you'll find the demos right there. And now over to Kevin, who has a slightly more complicated bio than me. So go ahead.
Thank you very much, Sander. So yeah, my name is Kevin Chant. I'm a lead BI analysis architect living in the Netherlands. However, as some of you can probably tell from the accent, I'm actually originally from the southwest of the UK. So basically, I'm an Englishman living in the Netherlands, working for a French-based company because he met a woman in Australia. Now, if you kept up with that, you're in a good place for this session. Now, I've worked in IT since the days of Windows 95. And that's probably as much as I should say about that. And over that time, I've worked in various sectors, including the banking, oil, and the health insurance industries. Now, it's safe to say I've gained a fair few certifications over the years, including the Microsoft Certified DevOps Engineer Expert certification, which is fairly relevant for this session. And in addition to that, I currently own a couple of GitHub partner certifications as well. Now, like Sander, I've recently been renewed for MVP as well. And in fact, I'm known as a dual category MVP because I've been awarded for both data platform and developer technologies. Like Sander, you can find me in various different ways online. I'm on Twitter, I'm on LinkedIn. I have my own blog where I post a lot about Microsoft Data Platform and developer technologies. And I have my own GitHub site as well, where I've got a few different templates people can use on there. So let's carry on with the session material. So when people think about doing CI/CD for SQL Server databases, they tend to think of doing a deployment pipeline like you can see on the screen here, where you deploy to various different environments in different stages. However, in this session, we want to focus on a couple of important things that must take place as far as testing is concerned before you finally deploy to your production environment, because there's some important levels of testing that should be done. Now, there are, as I mentioned, various levels of testing, and the three most important types we're going to cover in this session are going to be unit tests, integration tests, and user acceptance tests.
So basically, a unit test is the testing of small individual components in your code. the scope of a unit test is very narrow because you only test those little pieces of functionality individually. It's a small effort to create, and it focuses, especially because I said this a couple of times, just on the individual units. Most people who start doing unit tests want to do too much in the unit tests, and I always emphasize make them as small as possible to make it easy to maintain and to see what actually went wrong. So why would you do any unit testing in Azure DevOps? First of all, it improves your visibility and reporting. You can visually see where your deployment went wrong. You can see which tests actually failed or were successful, and you can report that to your team or to management to make sure they know all about it. It gives you more control and correction because you actually don't do any deployments if your tests fail, so you have more control before anything gets released, and you have time to correct it because you already know what went wrong, and then it's more efficient. Talking about efficiency, because we have the visibility, control, and the ability to correct, you're more efficient with your development, and that increases the speed of your deployments. And that comes into the planning and predictability because you can plan on what actually goes wrong, and it's more predictable what actually is going to happen during deployment in other stages of your development, going from test to acceptance to production. And in the end, the customer is more satisfied because we don't end up with a lot of bugs in production, because that costs a lot of time, a lot of money, and rollbacks and everything. So overall, this is a good thing to do. If we go and look at the anatomy of a unit test, it normally consists of three different elements. It's the assemble, the act, and the assert part. In the assemble part, we assemble all the parts that we need to do our test, like declare variables, executing some commands that retrieve values. In the act part, we go into executing the piece of code that we want to test. So that's where we actually run that piece of code. And in the assert part, we take all the stuff that we did in the assemble part and the values that we got from the act part, and we assert them together and see what if our test was actually successful or not. In this slide, you see how that is actually set up. So you can see the assemble part, we declare a couple variables, we fake a table, which is a command in T-SQL to make sure that we don't do anything wrong with the production table. And then we set an expected value. So we have everything collected that we need for the next part. In the next example, you see the act part. So it's here we actually execute the store procedure that we want to do. So we create a people. It's a really weird example, but we don't create people.
I thought you'd done that a few times already, to be honest.
Yeah, I already have 3 kids, so I should probably delete this store procedure. But this is how we should execute our code. So this is going to create something new. This could be any kind of piece of code that you want. And then in the next example, we have the assert part, where we check the expected and the actual value. This could be a value, this can be a table, or if an object exists or anything like that. But in this example, it's just checking if these two values are the same or not. So what can T-SQL do? It can do a lot of things. So first of all, it can mock tables, like you saw in the example. So it will actually make some kind of virtual table for you, so it doesn't do anything with the current underlying schema. You can do the same thing with views and with functions. You can assert on entire tables. So, and it's works really well because you don't have to sort all the values. It will figure it out for you. You can do the same thing for the individual values, like you saw in the example. And we can check for object existence, which would be a good thing because we want to know if that index is there or the table or the stored procedure. So that is a really valuable part, and you'll see that later on in my demos as well. We can handle exceptions. So one of the things people forget with unit testing is that we want to test on failures as well. So if we execute a stored procedure with a wrong kind of value, we want to get an error back, right? So you can handle exceptions like that and test if the right exception is returned. And in the end, we can return the results in an XML format that can be interpreted by Azure DevOps in like a NuGet kind of style format to get that can be interpreted and even get nice little pie charts being created with successful and failed tests. So to use TSQL, we need to do a couple things. There are some requirements to it. And this is why you don't want to do this on a production database. First of all, you have to enable CLR on the SQL Server instance for the unit tests to work. You have to install the TSQL framework, which installs a whole bunch of tables, which you will see later on, and some DLLs as well. You have to create at least one test class, and a test class is basically a schema. And you have to create at least one unit test, otherwise it's just not going to work, right? So these are the requirements you need for TSQL. Some tips before we can continue. Create multiple test classes. Don't put everything in one basket. And what I always do is I separate my basic unit tests like object existence and checking for basic, like if the tables are there or anything like that, in one test class, and integration testing, which we will talk about later on, in another test class. That way I can execute all the tests in a particular test class. For instance, if I only want to do the integration testing, I don't have to go through the basic unit tests. Give it a descriptive name. Don't name your tests something like test 001. You have like 250 characters for a name in an object. So use that space. Call it something like test if stored procedure X executes or it generates value Y, something like that. That way you will know for certainly what is actually done in that specific test, and it's easier to look up where where something went wrong if you have a failed test. Start your test with the name test ... So that way you always know that it's a particular test. And the most important one, and I mentioned this before, only one assertion per unit test. So don't make the mistake to do multiple assertions in a single unit test, because you won't know which assertion went wrong at some point. So you can, it's a better option to have like 20,000 to 40,000 different unit tests than having like a couple hundred with a lot of assertions in them. Make them as flat as possible and as many of you as you can. So yeah, so I'm going to show you how you can do this with SSDT, and how you can use some of my tools to actually generate a bunch of these unit tests to get you started. So I'm going to share my screen. Share screen. There we go. So
I will stop sharing my screen because
otherwise it's not going to work. So I have a template for SSDT because I'm really lazy when it comes to repetitive things. I created a template using the PS module development PowerShell module created by Friedrich Weinmann that enables me to create a template of a directory and replace some values in it. And that way I can generate my SSDT project in a matter of seconds instead of going through a wizard. So this will check a lot of things for me, and it's going to download this SSDT with TSQL template from my GitHub page. It's open source. You can just use it. If you find any problems with it, by the way, you can make changes to it and create a PR, and everybody will be happy. So if we run that code, and it does a lot of things, but the most important part of this is the invoke PSMD template, which will create the actual project for me. So let me run that. So what it's going to do is going to download the latest version of the template and install that locally. And that was it. It's already done. If I open that, and of course Visual Studio opens in a matter of seconds. So as you can see, there are two different projects in my solution. A data and tests are separated. So what you normally want to do is put your data model in one project and all your tests in another. And I did that by creating the data model, and then here is a reference to that other project as well. So I don't have to do this twice. I can separate the tests from a data model because you don't need to, if you do a deployment, you don't want to have your tests in your deployment if you go to production. So this is my project, and I can normally import the module or all the objects in there. But for the time being, we're going to go continue. And I'm going to show you in the next part, which is going to be really cool. In the meantime, I'm going to create some objects in my database, just some random database with some random objects. And we're going to create some basic unit tests. I created a PowerShell module called the PST-SQL test generator, which is on the PowerShell gallery, and you can generate your unit tests, your basic unit tests automatically based on all the objects in your database. It's also on my GitHub page. It's open source, so if you find any issues, again, create an issue or fix it yourself and create a PR so that other people can benefit of that as well. Let's see if it's already done. Yep. So what we're going to do is we're going to run a little piece of script called invoke PSTG test generator. And it's going to look at your database, go through all the different objects like your tables, store procedures, all your indexes, your views, everything, and then generate unit tests based on that. So let me run that. And in this case, I'm automatically going to output all the unit tests to this folder in my unit testing project. And it's going to be in my test basic folder. This is one of the test classes that I was talking about. So I have a test basic and a test unit testing. So you can see in the background, it's doing a lot of things. It's going to generate a lot of unit tests for me. And you can see that it actually did a lot of things already. It should be done by now. Yes, so it generated about 100, a little less than 120 unit tests for me in a matter of seconds. I can import that into my project, so it's in source control as well. So if I go in here, say yes, everything. And I'm just to see and let you see what is in here. So I'm going to make this a little bigger. So this is one of the assertions that we have, like assert object exists. It's going to check if that is actually in there in my database. If it's not, if it's a different name or anything like that, it will fail the unit test. And this is how you can do, you can start doing unit tests for your database project as well. This is another one that tests if the store procedure has the correct parameters, and also the parameters have the correct data type and everything. So it goes really deep if you wanted to go. So you saw me do this in like 5 minutes time. You can do this for a bunch of databases at the same time, because if you can do a little PowerShell, you can do this for all your database projects in a matter of minutes. So there's no excuse not to start with unit testing if you want to. That was my demo. I'm going to stop sharing my screen so Kevin can continue.
Yeah, so obviously carrying on from what Sander was just talking about there, he was showing you how to do it and saving all of those T-SQL units to your local Git repository on your machine, which is basically a folder you've got set up and you have got initiated. Now, just bear with me a moment so I can actually share the reference screen. So once you've actually done that initial commit of your Git repository of your T-SQL objects, you probably want to clone, copy, whichever term you prefer to use, all of those files into a repository in Azure Repos, which is the service you use to save your code in Azure DevOps. So, for example, here, and Sander, just to check, you can see my screen okay, yeah?
Yeah, I can see it.
Good, good. So, this is basically a very slightly modified version of the project that Sander just showed you just now, which contains the schema that you want for your core database effectively, which is what you want to go from all your different stages to production. And as well as that, the other project which contained all your T-SQL objects. So from there, you want to look to create a deployment pipeline, a bit like we showed earlier, where you deploy to all the different stages. But first of all, you want to do those unit tests at the very beginning. Now, there's a few ways, couple of different ways in Azure DevOps you can create your deployment pipelines with your unit tests included. We will cover both of them for you now. The first one is what's known as using Classic Editor and the releases feature, and these are both GUI-based methods. So the idea is you use the Classic Editor to create your artifact. Basically, you create your object, and then you would use the release feature to do the deployments. Now, if we look here in the Classic Editor, you can see it's all a nice GUI format, and all the stages you can view in a nice lateral way. And we've decided to show you this way first so that you can visualize what happens. But this is essentially the same task that takes place in the YAML pipeline, the YAML code, which we will show you shortly. So first of all, if you want to create the artifact that contains the two DAT packs, we build the core database schema project. So basically, this first DAT pack is the one that contains all the database objects, which we want to end up in every single stage, including production. We then create a separate DAT pack for those T-SQL objects that Sander was showing just now. And the idea we do those separately is because, like Sander mentioned earlier in this session, we don't want those to be deployed to the production environment. So carrying on from there, we then copy the created DAT packs to a location on the Azure Pipelines agent. And so for those who aren't aware, just help with a bit of jargon here, the agents and Azure Pipelines are the workhorses. They're the servers behind the scenes that do all the work that you specify in your pipelines. Azure DevOps doesn't do the work for you. It passes it on to these other servers to do all the processing. And finally, if you're using the Classic Editor, the GUI-based Classic Editor, you publish your artifact into Azure DevOps. So if I show you, for example, one that's already been done, you can see that there's an artifact created. And if I drill down, you can see those DAT packs are created. Once those DAT packs have been uploaded as part of the artifact, you can then specify them in the releases feature. So again, the releases feature is a GUI-based way to do your deployment pipeline. So here you can see you actually download those artifacts the artifact you created with those DAT packs in. And then straight away, we're going to a unit testing stage. Now, I will click on here to show you step by step the processes involved here. So first of all, we look to download the artifact just to make sure they're definitely on the agent. We then run a Azure prerequisites PowerShell script that Sander wrote, which basically just checks that certain PowerShell modules are installed on the agent before we carry on doing anything else in the pipeline. We then install the DAT pack, which contains the main database schema objects like we showed you earlier in the build phase. So this will do the deployment to the SQL Server databases of just those core database objects, excluding the T-SQL-T objects. However, for the unit testing stage, of course, you want to deploy those unit testing objects there. And then once that is done, and once we've deployed both of those objects to the database, you will end up with a SQL Server database that contains those objects in. Now, for the benefit of this session, we have actually slightly modified Sander's SSDT generator so that we can show you how the database looks on a local Docker container. However, if you use Sander's SSDT generator, it will actually create Docker images on the actual Azure pipeline agent and then install the unit testing database there for the test to be performed. But this is to give you an idea of what happens to the database on the agent. So as you can see here, this is all the core database objects that get created. And then you can see, in addition to that, afterwards, the T-SQL-T objects there. And if we go to the stored procedures and I scroll down, you can see again, all the actual stored procedures we want to be deployed to production, as well as all the T-SQL-T unit tests we want to be installed just on this one particular database to be able to do the unit testing. Now, once we've deployed those objects, we actually want to run the unit test. Now, usually you would do an execute of a unit test command. However, Sander has very kindly wrapped this all up in a PowerShell script to make it a bit more resilient for everybody. So what we can do here is open it up here I can just quickly go through what happens. I'll make this a bit bigger for everybody. So basically, Sander has been quite kind and he's actually validating that all of the parameters that get entered as part of the arguments you put in here on the right-hand side are all actually valid. So if I scroll down, once he's checked it's all valid and that the database actually exists, all we did then to run the T-SQL-T unit test is execute this stored procedure. In reality, you can run individual tests as well, but obviously clearly for bulk unit testing, just use to run all one. And then if I scroll further down, he then exports out the results using a nice XML result formatter. And that very kindly creates a file in an XML format. So once you have those XML file in place, you can actually publish that XML file, which is the output of your T-SQL-T unit test, into your pipeline in Azure DevOps. And I will show you how that looks. If we go back into this release, you can see here that I've got 100% complete, 100% even complete sign. If I click on there, you can see that it indeed does show me the outcome. All the tests have passed okay, none have failed. I get a little trophy to say that's all okay. And as you will see when you look at the YAML mechanism for it, the output is slightly different and you get the donut chart that Sander was talking about earlier. You don't get the same outputs between the release and the YAML pipeline, which I will show you in a minute. So doing this means basically that once your unit tests are completed, if there are no errors, your pipeline will continue and you can deploy to the other stages. So the typical ones like integration stage where you do integration tests, staging environment where you tend to do user acceptance tests, and then finally production. So it is a really good idea to do the unit testing at this level before it goes any further to those different environments. Now, I did mention I would show you the other way of doing it as well. So if you are using Sander's SSDT generator, this is the YAML code you get to create the YAML pipeline. However, we decided to show both in this session. So if I scroll down here, what I just want to highlight is that this is basically the code format of the GUI-based task you saw earlier. So plus, because we're using a YAML pipeline, we instead of using separate mechanisms to build the artifacts and then release them, we can do it all within the same YAML pipeline if we want to. So here we're creating the DAP packs again as part of the artifact like you saw earlier in the GUI-based version. And I won't focus too much on these tasks because they are the same as what you saw in the GUI-based method. They're just in here as code. And then from there, we are doing the unit testing, which again uses exactly the same logic as you saw in the GUI-based releases feature earlier. Now, as I mentioned, there is one subtle difference when it comes to the output. So if we scroll down, you can see all the different stages have completed, the same as before. However, you can see that the text is very slightly different here. And if I click on here, you can see indeed we do get some similar format, but slightly different way of what's happened with the test results here. And I could do some various other things. So we thought we would show you both versions of this and how it works in the pipeline. So
just a small T-SQL recap. By the way, T-SQL is an open source framework which is available just to install. You don't have to pay anything for it, so it's free for everybody to use. It's used to create your unit tests using T-SQL. So that is the most important thing with T-SQL. You don't need to learn another language for it to work. So you don't need PowerShell or C# or anything to create the unit tests. And it requires T-SQL as well. So the database developers don't have to go out of their way to learn something new. There's some prerequisites, so don't run this on a production server or anything like that, because it does change some things or it needs some changing to the server. It can be part of your DB project, like I showed you with the template, and I highly advise you to do that as well. And like Kevin expertly showed, it can automate your Azure pipelines in a brilliant way to get your test results in one of the steps.
Indeed. And like Sander said, he does actually have an SSDT generator you can use as well, etc., for those pipelines.
Yeah, the YAML files are actually in the build folder, so you don't even have to create your own YAML file. It's already generated for you. So it's just import that template and then you'll be good to go. So one of the things we have next to unit testing is integration testing, and they are very much alike, but with integration testing, we test different pieces of code. So you kind of integrate different parts of the database, like a module way, like the different store procedures. So you want to see what one store procedure is executing, and then maybe it affects the execution of another store procedure in the same piece of code. That's actually the next item, Kevin. Because we are testing different pieces of code and the effect on different objects in our database, the scope is very wide. So it's a larger effort to put together, and it's usually done to see what the effect is on different objects in the database. But it's an important part of your unit testing in general to put in these tests. So start with the basic stuff and then eventually go into the integration testing to really dive into what your store procedures and your functions and other programming stuff in your database is doing.
So there is another type of test you can use as well, which we thought we'd briefly mention that I'll quickly show in this session, and those are smoke tests. Now, smoke tests are also known as mock tests, and basically you can use them to simulate connectivity to something else. For example, a common thing that people tend to use is a smoke test to connect up to a fake API to check that some functionality would work in another environment, but you may not necessarily want to set it up outside of your production environment, as I just mentioned here. So I can quickly show you in Azure DevOps, if I go back into it, there is actually an extension that you can use that can help with doing these smoke tests. So if I go to the marketplace and type in smoke test, search, and as you can see that there's various different extensions, including the one that's got over 3,000 downloads, which is the one that I'm going to use for the demo in this session. So if we now go back to a releases mechanism, I can show you an example of how this works. So if we go back to the pipeline I showed you earlier, you'll notice that the integration environment has 3 tasks, whereas the others have 2. And that's because I've added an additional smoke test to this particular task. So if I bring some landscape back over, I just want to show you how simple it is to do these tests. You just put in the URLs you want to check exist in this task, and whilst it's doing the pipeline, it will go through and check if they exist or not. Now, it quite clearly does not exist, so if I was to run this pipeline again right now, it would flag up as a failure and would stop at the integration stage until I resolved the issue. So we just wanted to quickly highlight that particular type of test you can do. And that very nicely brings us on to Azure Test Plans, which can be used to manage manual tests instead of spreadsheets. So which I personally think is good because you have all of your test cases in one central location, and it also introduces some interesting functionality you can take advantage of because you can do things based on what's in Azure DevOps already. In addition to it, they also removes the risk of something I call spreadsheet sprawl. Now, to give you an example of this, you could be testing various things on a spreadsheet which you think is a single source of truth that is shared somewhere. However, you could have a project manager who's actually using a copy of the spreadsheet that they've saved somewhere else. And then to add on top of that, somebody else is actually using a completely different copy of the spreadsheet that they've got in their inbox somewhere. And that's something, like I said, I call spreadsheet sprawl, where you end up with multiple copies of the spreadsheet with different levels of the information inside them. Now, you'd use Azure Test Plans to cover manual tests, and a couple of popular ones you would use to test are user acceptance tests, like we showed in the pipeline earlier. And that's where obviously users would test updates in a particular environment. And also potentially exploratory tests as well. For example, if you're doing tests on a new feature you're thinking about deploying. Now, you need certain licenses to use the full functionality of Azure Test Plans, either Visual Studio Enterprise subscription or a Visual Studio Test Professional subscription or MSDN Platforms one, or a basic and test plans license in Azure DevOps. Now, just to elaborate a bit more on that, on the licensing side in Azure DevOps, you basically have three main types of licenses you have, or user levels. You have stakeholder, and those are basically people who have got read-only access to various parts of your Azure DevOps organization. Then you have a basic license, and this, to be fair, gives you more than enough functionality to do most of the things you need to do in Azure DevOps as far as working with repositories and pipelines are concerned. And then finally, you have basic and test plans, which allows you to take full advantage of Azure test plans. Now, without going into too much detail, there is a significant price difference between the basic and the basic and test plans license. The last time I checked, it was quite a bit more to have the basic and test plans license. But obviously, you may want to check and see if you're covered some other way. My piece of advice, if you're doing it for people within a small team, is maybe get the team members who've got an existing Visual Studio Enterprise subscription to work with the test plans if you want to save costs. Now, as far as the structure of Azure Test Plans is concerned, I like to think it's semi-structured because you can actually just create a test plan and then create test cases straight away. Or you can create multiple test suites to have all your different test cases in. Now, talking about test suites, and don't worry, I will show these in a minute. There are three different types of test suites that you can have in Azure Test Plans, which are static suites, requirement-based suites, and finally query-based suites. And I'm going to go through right now actually how they all look and their functionality. So let's dive straight into Azure Test Plans. And in order to do this, before I forget, I'm actually going to use a different project to do this particular demo. And this particular project is one that was pre-populated and created for me as part of the Azure DevOps demo generator. Now, this gives me a good chance to introduce some of you to Azure DevOps Labs. These are various lab environments that contain exercises that you can go through to get a better understanding of things in Azure DevOps. For example, if I click on this particular one to do with test planning, it will give me a link to go to the prerequisites. If I just click on the back here a minute so I can make it a bit bigger. I click on the prerequisites, it then asks me to follow the link to the demo generator. And this alone is something I really want a lot of more people to start using because it is really good. So the idea is you choose a template. Now you can think of a template as basically a pre-populated Azure DevOps project that you can use to do experiments with. So then you give it a name, you select your organization, and then you click the Create Project button. And that's exactly what I've done for this particular demo. So this project was created using that demo generator. So if there's one thing I want you to take out of this, it's definitely that. So here is one particular test case that I created earlier. I'll quickly show you this one before we go through the different types of test suites. So if I open this particular one up and improve the landscape a bit on this one. So as you can see, when you go to create a test case in Azure Test Plans, you can add your individual steps here. You can give it tags. It's basically like when you're dealing with work items in Azure Boards. You can add attachments to these items as well. And then as you can see here, if I scroll down to the bottom, scroll over, you can see I've added an attachment, and I've done that for a very good reason. I've added a JPEG file. And then once you've added changes, you can save and close. So you put all the things you want to test here, basically, all your steps, and then you save and close it. From there, you can go to execute your test case. So if I move this over to get some landscape back. Now, you can run it, you can install a desktop application to run these actual test cases. However, if you do want to install it, first of all, you've got to have permissions on the machine you want to install it on. And secondly, it will only run on your default monitor. So if you have multiple monitors, you're going to have a bit of work to do to get it to work on the right screen. Anyway, I'm just going to run it as web application. And as you can see, this is the step that I set up earlier in that test case. And one thing I want to highlight, as you saw, I added a JPEG as an attachment. And if I hover over it, I can actually see that JPEG here, zoom in. Now, depending on how functionality works, I can click on the tick or the cross over here. If there's a problem, for example, I could type in a comment like it broke. And then once I've done that, I can go to create a bug. So if I click here, it will automatically open up a bug for me to create in Azure Boards, which brings up another very important point. If you want to use Azure test plans, you must have Azure Boards enabled on your Azure DevOps project. Otherwise, you will not be able to use it. So as you can see, it's already added in the comment that I put in earlier. And then I can just create that bug. Now, going back to the actual test case, there's other things I can do. Capture screenshots, record what's happening. I can even record the screen with audio if you really want to for a particular reason. And add an attachment as well, so any other subsequent error logs that you found. So that's the test case, which is the smallest individual component you work with in test plans. However, like I said, you can logically group your test cases into test suites, and there are 3 available. So first type is static, like you can see here in the demo. And basically a static suite is that I have full control of which test cases appear. Then there's requirement-based suite, which is the most popular one, to be honest. And this allows you to query your work items effectively, and then you can select which work items you want to create test suites for. So let's grab a bit of landscape back here so I can actually, as you can see more. So for example, here you can see I've selected the top 3 results returned. I could filter up here. For example, I can add to only get back work items for certain tags, etc., which you may want to do if you're deploying a complex feature. So if I click on Create Suites, and we wait a moment, you can see I've now got 3 new requirements-based suites, one for each of those work items that I selected. And within there, it will bring back any test cases that you've already created as part of those work items. Now, the other type of suite that you can create, if I get this back here, is the query-based suite. Now, this allows you to actually query, if I zoom in a bit, the test cases that you've already created in various work items in Azure Boards already. And just like with the requirements-based suite, I can add other clauses here. For example, I can query for particular tags. So, for example, if you're deploying SQL Server 2022 in the near future, you may want to give them all of the tests a SQL Server 2022 tag, which you can then search for. So I could run a query, and again, as you can see, I've got 72 work items back here. I'll be adventurous. I'll click on Create Suite. And what that will actually do, it won't create 72 separate suites. as you can see, it actually creates the query-based suite with all of those 72 test cases inside it. Now, something that a lot of data platform professionals will appreciate is that this query-based suite that gets created is actually dynamic. So going back to my SQL Server 2022 test case scenario, if we were to create this and then create another test case in a work item and give it a tag of SQL Server 2022, it dynamically would get added to this test suite. So as you can imagine, there are some good possibilities of this particular one as well. So there are additional functionality as well. For example, we can create charts about various things here, various different formats as well, so we can show it alongside these suites. If I expand here, you can also see there's another progress report. For people that work with things like web applications, there's more advanced things you can look to work with, like parameters for your test cases and configurations. So for configurations, for example, you can set different operating systems and browsers. So you can check all of those as part of different test cases. One more thing I want to highlight as well is that there is actually a Azure DevOps extension you can install to be able to export of these test suites into a Word document. So for example, if I click here, as you can see, it brings up another window for these results. If I click on open, I actually download a Word document, which I can then open up. And of course, it's decided there to open it on a different screen, so just carry it over for you. So as you can see here, I have a Word document for all of those different cases and the test suites that I've created. So if you may want to experiment with this, for example, if you had to send the reports to your tests to people higher up in the business. Anyway, just to recap about Azure Test Plans, it can be used instead of spreadsheets, and I can't stress this enough. I really do think this is great. You need the above basic license to get the full functionality of Azure Test Plans. They have Azure Test Plans as a semi-structured hierarchy. As I showed you just now, there's 3 different types of test suites. And if you want to go through that again, I do have some blog posts and some examples relating to that as well. And there are very good examples of how you can work with Azure Test Plans and Azure DevOps Labs, as well as I showed you earlier, the Azure DevOps demo generator, which will create a pre-populated project for you so that you can experiment on these features inside Azure DevOps. And if you're going to use that, I do recommend you use it in your own Azure DevOps organization you've created for testing purposes. Try to avoid doing it on your work one if possible, unless, of course, you'll want to team up with your colleagues to do things. So,
well, that's all of our session. And I wonder if there are any questions.
Have you got any questions in the chat up here at the moment, Sander, by any chance?
Nope, no questions so far.
Okay, well, whilst we are waiting to see if there's any questions, we just thought we'd bring up our details on the screen again for everybody in case you want to reach out to either of us about any questions after this session. So we just leave them there briefly because there are a couple of other thank yous we have to do in a minute. So, and in case anyone's trying to jot these down, you can, of course, do a print screen to get these, or just search for either of us online.
Thank you, Kevin. Thank you, Kevin and Sander. We don't have questions so far. and I request all the attendees to put up their questions in the chat window if you have any. And I've also given the feedback link in the chat. Please go ahead and provide the feedback as well. And some comments are coming up. Kevin, just saying, great session, Kevin and Sander. People are commenting. Yes, but no questions so far.
Good. This is a brand new session exclusively for this event. So we're glad that people are enjoying it. And of course, because we're taking part in this event, we wanted to remind people that you can, in fact, win prizes today as well. I should really double check online shortly to see if there are some selfies of people appearing online. Like Amit was saying, we really appreciate session feedback, by the way, because like we said, this is a new session that we've done especially for this event. So we'd like to hear people's thoughts about it.
Thank you, Kevin. Bye.
Okay, so there are no more questions.
Well, if there are any questions after this session, feel free to send either Kevin or me an email, and we will reply as fast as we can. So.
Yeah. And that's where we show this, so you can reach out to the pair of us. Either way, obviously, Sander, admittedly, is pretty much the fountain of knowledge for all things relating to T-SQL T. As
there is one question, Kevin. Just Richard is saying serverless question mark. Serverless. Not sure about the question.
Serverless?
Yeah, they just said serverless question mark. That's it.
Does he mean serverless deployment?
Richard, could you please elaborate your question? Richard?
Because we kind of did that in the past, right?
Unless the question is relating to serverless Azure SQL database deployments. So yeah, if we can have a bit more detail about the question there, then we'd be able to answer it for you.
Yeah, can this be applied to serverless deployment? That's the question.
Serverless deployment to, for example, Azure SQL databases. As far as I can recall, yeah, they do support the state-based AppPack deployment method. However, obviously, it would take a bit longer to do because your database, your resources will have to spin up, if I remember correctly, if you're referring to the serverless Azure SQL databases, of course. If it's for Azure Synapse serverless SQL pools, that is a very different situation, and please reach out to me and I can discuss that with you after this session.